Hey everyone, welcome back to the fourth part of our staking DApp project. In the last part, we have deployed our contract, tested our contract, and we have done all the setups. In this video, we're going to write our context management code. So this is where we left in the last video. So make sure to come here. This is what we have. Open up your context file. In that, we have all of this file. So first, we'll start with constant. After that, we'll go back to the index file. So first, we have to come back here. This is what we have coded and we have deployed in the previous videos. And now we're going to start working on our context. Click here. And first thing, we're going to import a couple of libraries. So let's do that. First, we have to import our ether package, and that's coming from ether. It's ethers, okay? It's not only ether, it's S. Then we have to import the ABIs. So let's call this staking DApp ABI, and that's coming from the same location, staking DApp.json. We got the ABI, and you can see here we have all the ABI, ERC20 ABI, staking DApp ABI, token ICO ABI. So we are importing all of these three ABI. So this one. Now we have to simply import the other ABI of token ICO, and it's coming from the same location, ICO.json. So we got the ABI. Now we have to simply import the custom ERC20 token ABI. So we'll say custom token ABI and ERC20.json. So we got the three ABIs and the ether package. Now we can import our environment variables. So let's call this contract. Let's call this staking DApp, and this particular address of our contract, which we have deployed and got in the last video, we are getting from our environment variable. So when you're going to make the changes in the addresses, all you have to do is to change in the environment variable in all the places. So now we have to simply import process.env, and this is what we have called next public dash staking DApp. So this is the address of our contract. If you come back here in the environment variable, click here, and this is all the addresses, all the variables. So when you want to do the changes in the ICO contract, reward token, deposit token, logo, admin address, that's all the configuration we have done here. So simply copy this one, make sure to give the exact variable name. Simply come and check that. So this is the exact variable, replicate that. Now we have to get the address of our token ICO contract. Come here, copy that and replace here. So we got the two address of our two different contract. Now we can go ahead. And now we have to import the other variables, so reward token and deposit token. So let's call this deposit token, and it's coming from our environment variable. So simply copy, and that's what we can paste here, and come back here, and we have to simply copy this, and that's what we can simply import. Now replicate this and change this to reward token. This is the logic we have applied in our smart contract. So you can reward the same token which one you are allowing user to stake, or you can simply reward different token. But in the actual world, in actual project, when we launch on a decentralized ecosystem or decentralized protocol, so we try to promote our token. So we allow user to stake the same token and get the same reward. So in that way, our project will kick off. It will get more popularity, more trading. So this is the strategy you have to apply. So we got our addresses, all of this. Now we can simply come back here and let's build a couple of utility function. So let's build our very first function, which will convert any number into ETH. So let's call the export function to ETH. In that, we have to simply pass the amount and a decimal point. So I will go with 18 decimal point because that's how we make the conversion. I hope you guys are familiar with way. So we got this to input. Now we can come back here. We'll take a variable called to ETH, and we'll say ether.utils format utils. And in that, we have to simply pass the amount and the decimal point. In that way, we can able to convert into ETH. Got it? Now we can simply return this. So we'll say to ETH, and we have to convert it as a string. So that's our first utility function, which will convert any number into ether. We got that? Looks good. Now we can move to the next utility function. So let's call this export const token contract. So this is going to be our native token contract, which we are allowing user to deposit. It's going to be an async, and we're going to build the provider and the signer, and then we're going to generate the token object, means token contract object. So let's do that. So we'll say const provider. We'll use our ether package, new ether dot providers, and we have to call this web3 provider. And in that, we have to simply pass the Ethereum object, which is there in the browser. So we can get that from window.ethereum. And you can able to have this Ethereum object whenever you install any Web3 crypto wallet. It's going to inject that Ethereum object in the browser, so we can get that, and that data is available in the window object. So that's why we are getting this. So once we have that, now what I'm going to do is I'm going to simply extract the Ethereum object. So let's do this Ethereum, and it's coming from the window. So I want to execute this function when there is a Ethereum object exist in our browser. So let's build a if statement. We'll say Ethereum, if it exists, then we have to simply generate the contract object. So we'll say contract object. So we'll say signer, and we can say provider dot get signer. In that way we can able to get the signer. Then we can simply come back here and we can simply generate the contract object. So we'll say contract render. In that we have to pass 3 information. So let's use our ether package. We'll say new ether dot contract, and it's take 3 argument. First is going to be the address of the token, because here we are dealing with the token contract. You can make it dynamic. All you have to do is to take the address of the token as an input, and that's what you can pass. But here we are going with the fixed value. We are taking the deposit token. I have to pass the ABI of our ERC20 token ABI, and at the end I have to pass the signer, means the user is interacting with our contract. So we'll have that data in the signer. In that way we can able to have the contract object. So once we have the contract object, now we can simply come back here, and that's the thing we have to return, because this particular function is going to be a reusable function. We have to call in multiple places. So first we are getting the provider and Ethereum, then we are making the changes and then checking the condition and creating a contract object, and that's what we are returning. So that's the very first function. Let's move to the next one. We'll say export const, and this will be our actual contract of our staking. So it's going to be in async. Let's come back here and we need this portion, copy, paste here, and we have to get this portion as well, because it's going to be the same thing, but all we have to do is to simply change the contract address and the ABI. So here we have this is going to be exactly the same. Here I have to give the staking tab address, and I have to change the ABI to be the staking DApp ABI. So this one, copy, and that's what I can simply pass here. And that way I can able to have the object of our staking contract. So we can call in our other function. So we got our contract object. Now we can come back here and let's call the export const ERC20, and this particular function will allow us to give the information about the token, which is very important. We have to display those information in the front end, and we need some of the information in our contract internally. So it's going to be an async, and it's going to take 2 argument, address and the user address. Actually this function is dynamic. All you have to do is to pass the address of the user and the token address, and it's going to give you the relevant information as per your address. So let's build that. So in that, what we're going to do is we need this provider, copy, and that's what we can paste. And we also need this object. Simply copy this one and paste here, and all we have to do is to change the address and the ABI. So we can simply change the address of this, the address we are getting from the user as an input, and then we're going to use the custom token ABI, which is for the ERC20 token. So we got our contract. This looks good, and remove this version because this is going to return the entire data about the token in respect of the address of the user. So what we're going to do is, here we have it, we have the contract. So let's call the function. So first we want to get the token. I'll take as an object, and there I can simply call that. So I'll take this name, await. So say await contract render dot name. In that way I can able to know the name of the token. I need the symbol, so let's change this to symbol, and this will be symbol, and this will be address, and this address is available. Simply remove this and address. So we got all of this 3 information. Now we can simply replicate that and change this to total supply, and here we have to make it this ETH, because the data will come in terms of way and we have to convert into ETH. So we'll use our internal utility function. This is the one, that's what we're going to call it, and all we have to do is to pass the amount. So we can come back here and we're going to simply wrap it and change this address with our function. So we'll say total supply, and that's the only thing we have to do. In that way we can able to have the formatted total supply. Now we can simply come back here, change this to balance, and here we have to call the balance of function. In that we have to pass the address of the user, because this time we are getting the address. So let's say user address. In this way, what will happen that we can able to know that how much token this particular user have in this particular token. So once we know his balance, now we can simply go to the next line. Let's change this to contract token balance, and this particular variable will tell us that how much token we have in the contract. So all we have to do is to simply come back here, and this is going to be exactly the same, and change this to contract staking contract address. In this way, we can able to know that how much token of this particular token we have in the staking contract. So balance is for the user, and this contract token balance is for the staking contract. So we know all the balances. So that's the entire object we have for the token, and that's what we are getting from here. I hope you guys can understand the logic. Now what I have to do is simply copy and return the entire data, so we can utilize in our function and in the front end. So that's the entire thing for our ERC20 token. I hope you guys can understand. Let me have a quick look one more time. Looks good. Now we can simply move to the next function. So we can come back here. Let's call this token ICO, because that's what we're going to do now, because all of this utility function, all the contract function we have built for staking contract, but we have two different contract. One is for staking and the other one we have is for the ICO contract. So now we're going to deal with the ICO contract. So it's going to be exactly the same. So let's build that quickly. We'll say export cons load token ICO, and it's going to be an async. And we have to take this try and catch if anything goes wrong. So we have to simply catch that. So let's come back here. So when the user will reload the page, this is the function we'll call, and it's going to reload all the data. So what I'm going to do is let's build this internal function. So we'll say contract, let's say contract await token ICO and contract. So this is the function we're going to create, which is going to give us the contract object. So let's call this one. Right now we don't have this function. So what I'm going to do is let's come back here and let's build that function. We'll say export cons token ICO contract. It's going to be an async, and we have to do exactly the same thing the way we have done on top. So we can come back here and we can get a couple of information. So simply select all of this, and that's what we can paste here, and all we have to do is to change the API and the address. So this is fine. We can change the staking with the token contract. So we'll say token ICO. So this is the ICO address, and we have to change the API. So let's call this token ICO API. And that way we can able to have the token ICO object, and that's what we're going to utilize it in our in our load token ICO function. So this is the contract function. Now what we can do is let's come back here and let's work on the other function before we actually go and write all the functionality for loading the data. So this looks good. Now actually what we can do is we can simply come back here, simply copy this entire portion, and let's build a separate ERC20 token function, and we're going to do a little bit modification in this. So the first one, ERC20, is for the staking contract, and this function is going to be for our ICO contract. So I'm going to change this name. I'll call it token ICO ERC20, and let's remove this one. We're going to have all of this. We're going to change the address to deposit token. That's the token we are allowing user to stake and get reward. So that's what we have here. Now what I'm going to do is, this looks fine. We don't do any changes here, but we need more information. So I'm going to call the contract render function and get some more information. So let's do one thing. We can come here. We'll call it user address, const user address, and this data we have here. So we'll say await signer.get address. So we'll get the address of the user. Let's replicate that. Now we have to get the balance of the user. So we'll say let's change this to native balance, and we're going to change this to get balance, and that way we can able to have the balance of the user. Now we can simply replicate this, and let's simply copy and paste here. Actually we already have the name, so we don't need that portion. We need this portion. So simply copy this. Let's copy from here, and that's what we can replace with, because we already have the name, and here we have to do the changes. So we have already provided the user address. It looks fine, and that we can able to have the balance of the user. Now I'm going to simply change this to balance. Got it? Looks fine. So these are the three data we got it, and we're going to simply adjust the format. So what I will do is I need to do the changes in that alignment. So let's bring this address on top. because this is what I have in my data structure. So I'm just following my data structure. This is the symbol, format it, replicate this, change this to decimal, and copy and paste here for the decimal. So we got that. Now we have to simply remove this for supply, and this looks good. Now we can simply, we need the balance, so simply copy and paste here. That's also look good. And here we have this. Got it? And the rest should be fine. Let me have a look one more time. And this is our contract token balance. So what I will do, I'll simply copy this one, and that's what I will paste here, and simply copy this and simply remove this one and paste this and convert to a, let's call this to string. So we'll have a formatted balance. So that's the entire data we have for this token. Looks good. This is what all we have. All of these details we got it, and that's what we are returning at the end. And that's the only thing we have to do here in this token ICO ERC20. So we are done with this. Simply pause the video and try to understand that what exactly I have done. This is very basic. Got it? Close this one and close this one, and now we're going to start working on our load token ICO, and this particular function is going to load all the data. So our internal contract function is ready. Now we're going to simply call it. So what we can do is we can simply come back here. We're going to simply take a variable called token address, and we can get that contract dot token address. That's how we can call it. Once we have that, now we can come here. We'll take a token details, and we have an internal function we have built in our ICO contract. So we'll say await contract get token details, and this particular function will give us all the details about the token which we are allowing user in our ICO contract. So if I take Q here, let's call this const contract honor. So we'll say await contract dot honor. So in that way we can able to get the honor of the contract. Now we can simply come here, we'll take this token sold, and we can get this data from our contract. So we'll say token sold tokens. So we got all of these details. If you come back here and go back to the contract, you will see here we have all the function we have built in our ERC20, and this is the function we are calling. All of this data we are getting, like token address, token sell price, and token sold, all of that, and that's what we are calling here. Looks good. Now we can simply come back here. Let's call this ICO token, and we're going to build our token ICO ERC20 function we have built. Is going to give us the entire extra information which we need. So let's call the function called token ICO ERC20. We got all of that. Now we can simply format the data and return it. So we'll take this variable called token, and let's format that. So first is going to be the token balance. We'll say ether utils format units and format ether. In that we have to simply pass the token details. This token detail will contain all the balance, all the information about the token. So we'll say token detail dot balance, and we'll pass as a true string. So we got that. Now we have to get the name. So we'll say token detail dot name. Then we can simply get the symbol. We'll say token details symbol. Then we can take the supply. We'll say ethers utils format ether. In that we can simply pass the supply to string. Got it? Now we can simply come here, and we have to simply change this to token price. Simply copy, and that's what we can replace here, token price. Now we can simply come here. We'll take this token address. We'll have this token detail dot token address. Now we can take the honor, which we already have. It's contract honor, and we have to convert it into a lower string because we have to do the comparison in the front end. So it would be better we should convert into a lower string. We'll say lower case, and at the end we'll have this sold token. We already have it to convert into a number. So that's all the details we have, and at the end we have to simply call the function we have built. We'll call it token ICO token, the entire token object. So that's the entire data we have about our token ICO contract, including the price, honor, sold, all the information we are getting in one particular object. This is the strategy you have to follow. You should never call separate function in different places. Make one particular call, in that get all the information and distribute the data. So that looks good. Simply copy, and that's the thing we have to return here in the function. And if anything goes wrong, we have to simply throw an error so we can see what exactly went wrong. So it looks good. I hope you guys can understand. This is the entire function we have. We are getting that. We are creating an object of the data, and then we are returning it. Looks good. Now we can come back in this particular function, and here we have to simply also, like this particular one, we can, here we have this. There's no try and catch. So let's add a try catch if anything goes wrong in this particular function. So let's do one thing. Let's minimize this one, and let's take a try and catch. So we'll take this try and catch, cut this one and paste here, and let's console log out the entire error if anything goes wrong. And that looks good. And we'll say error. So that's the entire code we have to write here in the constant. So let's have a look. So this is the import we have done. We got our addresses. Like, we're going to do the testing. If there is any changes need to do, we're definitely going to do that. We're going to do more testing to make more flexible and easy to interact with the data. So this is the structure which we are following, but we're going to do the little bit modification as well. So we got this utility function. This is the token contract. Then we have the actual contract, all of that. Then we have our ERC20 with all the data. Then we have our load token ICO. We're getting all of this, returning the entire object. Then we have our token ICO contract and the token ERC20. So that's all information we have. Looks good. I hope you guys have understood so far. We are done with this. Now we're going to move to the next one, which is index. Here we're going to write all the function which allow us to write the data in the smart contract. So this is the general structure we follow in the industry. One is for read the data and the other one is for the write the data. And that's writing data function we're going to write up here in the index file. So first thing, we're going to import couple of things. So let's do the import. We need big number and we need ether, and that's coming from the ether package. It's ether. Once we get that, now we can simply come here. We have to import our toaster for the notification, React hot toast. Once we have that, now we have to simply import the functions. So we'll go to the constants and let's import the function because we need the token contract object and contract object. So we'll take this contract, token contract, ERC20, then we need the 2 ETH, and the last one is going to be the token ICO contract. These are the contract we are importing for our constants. Now we can simply come here. We need to copy the address of our staking contract. Let's import here. And we can come back here and go back to the environment variable. Just keep it as it is. This looks fine. We can come back here and we need this. Copy the address of deposit token and reward token. We got that. And change this to token logo. Because in our environment variable, we have the logo of the token, because when the user will click on add to logo, we are adding this particular image. And that's what we are importing. So this is the entire import. If we find we need to do modification and import more variables, we'll definitely do that. But let's go with this first. Now we have to create our notification. So we'll take this notify success. In that we need to simply pass the message. We'll call it toast success. In that we need to pass two things, the message and the duration. So the duration is going to be in seconds. So I'll go with 2 seconds. This is going to be an error. So we have to call the error method and this will be error. So this is our notification component. It's ready. We're done with that. Now we can simply come back here and let's try to build the functionality. So let's write a couple of utility function. So first is going to be a converting time into a readable format. Let's build that particular function. So here I'm going with a regular function, or you can take a normal async function. It's absolutely fine. So let's call this convert timestamp to readable. In that we have to pass the timestamp. Then we have to build the logic. So it's very easy. I'll say date, new date. In that we can simply pass the timestamp and multiply with 1000. Got it? Now we can come back here. Let's create the entire object of the time. So we'll call it readable time. We'll take this date dot to local date string. In that we have to provide that English US, and then we have to simply design the entire date format. So first is going to be the year. I'll take this number. The second one is going to be month, is going to be 2 digit. The third one is going to be day, is going to be 2 digit. Then an hour, same 2 digit. Then minute, 2 digit, and the last one is going to be second for 2 digit. You can play around with these variables. Okay, it has multiple format, but I'm going with a simple approach. So we have that. Now at the end we have to simply return this data. So we'll say return readable time, and that's our first utility function for converting timestamp into a readable time. Looks good. Now we can come back here. Let's build another function for way converter, because this one is also important. So let's call this to way. It's going to take the amount, and we have to follow the same logic we have follow in to ether. So we'll take this two-way ethers utils parse units. In that we have to simply pass the amount and convert it to a string, and at the end we have to simply return it. So we'll say two-way into a string. So this is our way function. Got it? Now we can come back here and let's build the next function called parse error. When anything goes wrong in our smart contract, it will throw an error. So we have to format that error in such a way so we can display it to our users. So it's going to take a entire error object. Let's format that. So we'll take this const JSON parse, and that we have to pass this JSON.stringify, and that we can pass the error message. If we have the error, it's going to give us the message. So let's build a dynamic condition. We'll say JSON reason, else we have to display the actual error message. JSON.error message, it's dot message. So what logic I'm following, that if there is a reason, a proper message, then display that, otherwise go with a simple reason. So that's our parse error message. Looks good, simple. Now we can go back to the next function called short address. It's very simple function. We'll say shorten address is going to take the address of the user and is going to have a simple return. So let's take a template rule. In that we can pass the address. We can simply slice it down from 0 to 8, and from the last part of the address we need the 4 character. So we can take the address dot length and use the slice method, and then we're going to say address dot length minus 4. So it's going to give us the last 4 characters, and I'm getting some sort of warning. Okay, I forgot to add this const. Now it's perfect. So what I'm doing here, I'm getting the first 8 character of my address, then I'm taking the address dot slice method, and then I'm passing the argument like I need to whatever the length is, just simply subtract with 4. So it's going to give us the last 4 characters. So we got this. Looks good. Now we can continue ahead and let's build the next function called copy address, because when the user will click on the table, they will copy the address. So it's going to take a text, and we have this particular method called navigator clipboard write text. So we'll say clipboard write text, and let's display the notification that you have copied successfully. So we'll say notify success, copied successfully. So this is the utility function we have built. Now we're going to write the actual function. So let's come here. Let's call export asyncs function, and this will call contract data. This particular function is going to fetch all the data about our staking contract, and it's going to be a little big. So it's going to take the address of the user. Let's take a try and catch. If anything goes wrong, we have to format the error. So first thing, we have to get the contract. So we'll have the contract object. Let's call the await contract. So we got our staking contract, ICO contract as well. So let's call that. So we'll take this staking token object, and we'll have this token contract. So we have taken both the contract for token as well as the staking contract. but we're going to deal with the contract object, which is the staking contract. Now what we can come here, we'll take a if statement. We'll say if address is there. If we have address, then we want to execute it and call all the functions. So let's build this if block, and in that we're going to build all the logic. So first we're going to get couple of information. So let's take a variable and let's call this contract owner contract object, and it's going to give the owner of the contract. Then we want to take another variable called contract address, and we have the address available on the contract object dot address. Once we have all of this data, now we have to get the notification. So let's call this notification, and it's going to have a array. So let's build that logic. So first we're going to get the entire notification. We'll say notification contract object dot get notification. So this is the function we have in our smart contract. So if you come back here, if you go to the contract section, there you will find that this is the function we have built, which is going to return all the notifications. Simply come all the way down, and this is the function we have. So simply copy, and that's what we have to simply call it, and it's going to give us the entire notification, but we have to format the data in proper way so we can display in our front end. So let's do that. We're going to take this const is going to be notification array, and we'll say await promise dot all. In that we have to take our notifications, and we're going to simply run a loop. So we'll say notification dot map, I will say async, and we have to get the data which we have in each notification. So we have all of this data. We'll have the pool ID, then we'll have the amount, then we'll have the user, then we'll have the type of, and the last one is going to be the timestamp. I hope you guys can understand that from where I'm getting all of this data. So if you come back to the staking contract, you will see this is the exact information. So you have to give the exact variable name, and that's what we are simply calling it. So once we have all of this, now we're going to simply make an instant return, and let's format the data. So we'll take this return, and let's call this pool ID, or we can do one thing, we can take it as an entire object. So we'll take this and let's bring that. So we'll take this pool ID is going to be the pool ID, and we have to convert it into a number. Then we have to take the amount, and we have to simply say amount, and we're going to use our internal function. So we'll take this to ether, and in that we can pass the amount and remove this. Then we have the user is going to be the user. Then we have our type of, so it's going to be type of to type of, and the last one is going to be timestamp. So we're going to simply convert this timestamp. So we'll take this convert timestamp to readable. In that we can simply pass the timestamp, and this is the entire data we are getting in each notification. So we got the entire data in a proper array. So we are done with this first notification. Now let's move ahead, and now we have to deal with the pools, because pool will also have a data in the form of array. So we have to construct in a proper way so we can utilize it in our front end. So we're going to take the length, because this length is very important. User can create as many pool as they want, and we have to run our loops. So we have this particular variable in our contract which we have taken. So let's call this pool info array, and it's going to be an empty array. So when we're going to run the loop, we're going to push every single pool in this particular array. Now we're going to simply build a logic. So we'll take a pool length, which we can get it very easily. We have this particular variable called contract object dot pool count. I hope you guys have remembered this. If you come back here, this is the variable which we are taking. This will keep the track of how many pools have created so far. So once we have the length, let's convert that into a number. So we'll say length pool dot number. Now we can build our for loop. So we'll take this for let I is equal to 0, I less than length, otherwise we have to simply increment it. If this condition is true, then we have to increment, and here we're going to build all the logic and we're going to make calls. So this is look good. Now we can simply come here, we'll take a variable called pool info, and this particular variable going to keep all the information about a single pool. So we'll say await contract object, and we're going to simply call this pool info, and in that we can pass the first one. So this is the one we are calling. It will keep the track of all the pools as a form of array, and that's how we're going to simply access. So we'll simply call it and pass the I. So it's going to increment every single time. So once we have the pool info, now we can simply come back here. You have to get the user info, await contract object dot user info. In that we have to pass two arguments, the ID and the address, this address. Got it? Now we have to simply get the pending reward. So we'll say pending reward, and it's going to take the same argument. Change this to user reward. So got all of this data. Now we can simply come back here. Let's take a variable called token info A. So now we have to access the data of each token, token 1 and token 2. So we'll say await, we'll say ERC20. In that we can simply pass the deposit token and reward token. So we'll take this pool info dot deposit, because this pool info will contain information about all the information, and in that we have the token deposit token, percentage, reward token. So we are accessing that. So let's call this deposit token. Got it? And we can pass the address of the user. Replicate this one, and this is going to be our reward token, and change this to B. So we got the two token information. That's what we have. You can see, make sure to check the spelling. Spelling is very important. So we got this token information as well. Now we can simply come back here. We got all of this information. Now we can simply format the data. So let's come here. Let's take a variable called pool, and in that we're going to simply format the data and we're going to return it from this particular function. So let's call this. So let's come back here. Let's take this deposit token address, and let's call this pool info deposit token, and this one is going to be for the reward. Change this to reward. So we got the address of the two token. Now we can come back here. Let's get the information about the token 1 and token 2. So change this to token A, and this one is going to be token B. So deposit token and reward token. Looks good. We are got the information of the addresses and the token object. Now we have to simply get the other information like deposited. You can see deposited amount. That's what we need. So let's call the deposited amount, and this information is available in the pool info. So we'll call our formatted function. We'll say pool info. In that we can call this deposited and convert it to a string. Got it? Now we can take this percentage, the pool info dot APY, convert it to a string. Then we can take this log day, and this information is already there called log days, convert it to a string. Now we can get the information about the users. We'll take the amount, we'll take this converter function. In that we can simply pass the user info dot amount, convert it to a string, and this one is going to be called user reward, and here we have the reward. So simply pass the user reward. Then we can simply come back here. Here we have the lock until, and that's what we can take it, simply remove it. We can use our internal function for converting the time, and we can simply pass that. So we'll take this user info, and we can pass it, convert it to a number. Looks good. Now we can simply come back here. Let's pass the last reward at, convert it to ether. So we'll take this user info, and this information we have here in the last reward at, like this one. Simply copy this one, and that's what we can call it, convert it to a string. So we got all of that. Looks good. Now what else we are missing? So we got all of that. We can simply come here, and we can simply push this data into our pool array. So like this push, and we'll say pool array. In that way we can able to have the entire data about each and every pool along with the reward and deposit, and we are storing as a array of object. So we got all our dynamic data. Now this is the information. Now we can simply come back here. Let's take a variable called total deposit. So we have to calculate that how many token deposited by the user and how many token we have deposited as a surplus, so the user can claim the reward. So that's the difference we need to get. So we can call it, first we have to simply calculate that how many tokens user have deposited in all of the pool, not in a single pool, all the pools. So you can do it very easily. I hope you guys are familiar with JavaScript. JavaScript is really powerful, which you can use it to design your own data structure. So we can do that. We'll take this pool array info. In that, we're going to simply call this reduce function. In that, we have to simply target it. So we'll target the total and the pool. That's what we are targeting. Now we can simply come back here. We can take this return. We'll take the total plus parse float, and we can simply take this pool dot deposited amount, because every single pool will have this particular variable, and that's what we want to access and add it. And that's the only thing we have to do. This is going to return that how many tokens user have deposited in all the pools. So once we have this data, and that's data, we're going to use it in the actual object. So let's come here. Let's take a variable. Let's call this reward token as an object, and that's what we can simply get it. So we'll call this await ERC20. In that, we can simply pass the reward token address and the user address, replicate it, and this one is going to be the deposit token address. Change this to deposit token. We are just designing this data as per our requirement, because this is the structure we're going to use in our front end for displaying the data. So you can play around with the data, but first I would suggest you to follow the way I'm doing it. We got it. Now we can come back here. Let's take a variable called data. So we have all of the data. Now we're going to simply assign it in our data, and that's what we're going to return it. So let's do that. First is going to be the contract owner, and we already have the address, contract owner. Then we have the contract address. We already have it. Then we're going to take this entire notification. We have the entire array, notification array, and I'm going to reverse it. So we'll have the latest notification. So let's call this reverse function. It's going to simply reverse the array. Once we have that, now we can simply take the reward token. We already have it. Then we can take the deposit token. Got it. Now we can take the pool. It's an array. We already have it. Now we have to take the deposited token amount. Deposited amount, we got it. Now we have to get the difference, that how many token users have stake in the contract and how many tokens we have provided as a creator as a surplus, so the user can claim the reward. So let's build a variable. We'll call this contract token balance. I just want you to give a try. It's a very simple function. We have to do a subtraction. So first thing, we're going to simply take this deposit token. In that, we're going to simply call this contract token balance. So whatever the balance we have about the token in the particular contract, we're going to simply subtract with the total deposit amount. So whatever value we'll get means that's the amount owner of the contract provided as a surplus. Very simple subtraction we are doing, and that's what we have here. Now we have to simply return the entire data. So we'll say return data. So this is the huge function we have written. First, we have imported our contract. Then we have got the information about the owner and the address. Then we have got the information about the notification and formatting the data in a proper array. Then we are getting the information about the data, about all the pools which user are creating. So we have taken the empty array. Then we are getting the length of our pool. And then we are running all this for loop and calling all the function we have, like pool info, user info, pending reward, and that's what we are taking as an array. Then we are simply calculating the total number of token deposited by the user in the entire contract. Then we are getting the information about the deposit token and reward token, and at the end we are simply formatting the data and returning it. Simple. Let's catch if anything goes wrong. So first we're going to say console.log, and we have to pass the error. So we'll say, and at the end we can simply return the entire error message. So we'll say return parse error message. In that we can pass the error object, or we can simply copy this one and replicate this and paste here, so we can see in our console as well. Remove this comma, and now it's look good. So this is the entire function. I hope you guys can understand. So let's close this one. Now we're going to move to the next function. So it's going to be a deposit one. So we'll say export async function deposit, and it's going to take a couple of arguments like pool ID and amount and address. These are the three information it's going to take for depositing the token. So let's take this try and catch if anything goes wrong. First thing, we have to simply display this notification that you have called the function. So we'll take this calling contract. Then we have to get the contract object. We'll say contract object await contract. We got that. Now we have to simply take the staking token object. We'll say await token contract. And the reason why I'm taking this staking token object, means the token contract, because first we have to check the allowance, and that's how the contract exactly work. You cannot able to transfer the token just like that in the contract. First we have to check the allowance and approve the allowance. After that you can transfer the token in the contract. So let's do that. If you just try deposit the token just like that, is going to throw an error. So let's avoid that. So we're going to come back here. We're going to simply convert this amount. So we'll take this amount in way ether dot utils dot parse units, and then we can pass the amount and convert it to a string, and we'll call it 18 decimal point. So we got the converted price. Now we can simply come back here. Now we're going to simply take this current allowance. So we have to check that what is the current allowance, what is the status. So we'll say await staking contract object allowance, and in that we have to simply pass the two information, like the address of the user and the contract address which we are allowing. So we'll say contract object dot address. So we'll have the current allowance status, and here we have to build a if statement. So we'll say if current allowance with our converted price. So if we don't have enough allowance, then we have to first increase the allowance. After that we'll allow user to deposit. So let's call this notification success approving token. Let's call that, we'll say approve transaction await. We'll take the staking token object, then we'll call this approve function, and in that we have to simply pass the information. So first is going to be the contract address which we are approving, and the second one is going to be the amount, our converted amount, and that way we can able to increase the allowance. So we have to wait for the transaction to be complete. So we'll take this approve wait, and we can console log out the information once this approval get completed. So we'll take this approve, and we can give the amount we have approved. We'll say let's call token for staking. So this much token we have approved successfully. Now once we complete this particular function, after that we have to go to the next function which is going to deposit the token in our staking contract. So we can come back here. We'll take a variable called gas estimation, where you have to always calculate the gas. You can go with the hard code value, but that's not the appropriate structure which you have to follow in the DApp. You have to calculate the exact value which you're going to provide during the function call. So we have this particular method in our ether package which allow us to calculate the gas estimation. So we can calculate it very easily. So we'll say await, we have to call our contract object. In that we have a function estimate gas. So this is the method we have, and now we have to simply call the function which we want to check the gas consumption. So we want to check the function for deposit. You have to pass the argument. So in the deposit we have to pass the two argument like pool ID and the amount. So when this particular function will execute, it's going to give you the exact gas which the function is going to cost. So once we have the gas amount, that's what we're going to provide it in our function. So let's come back here. Let's build that function. So first we have to display the notification. We'll say staking token calling. Take a variable. We'll say stake transaction await. We'll take a contract object and call a deposit function, and we can pass the exact variable pool ID, an amount, and our gas fee. So we'll say gas limit, and the gas estimation we have calculated. This one looks good, and that's the only thing we have to do here. Looks good. First we are checking for the allowance. If it has enough allowance, then we have to stake the token, but if it don't have allowance, we are increasing the allowance, then we are allowing user to deposit token. So that's our dynamic block we have. Once we get that, simply convert into a number. Got it? Now we can come back here, and we have to simply wait for the transaction to be complete. So we'll say receipt wait. We'll say stake transaction dot wait. Once the transaction is complete, we have to simply display the notification that token take stake successfully, and at the end we have to simply return the receipt. And here we have to simply build the error message. So first we're going to simply console log out the error, and we already have the function called parse error, so we can simply format that. So we'll say error message, we'll call our parse message error, and then we can pass the error object, and it's going to give us the error message, and that's what we can display in our error notification. Looks good. Got it? I hope you guys can understand that what exactly we have done. This is very crucial, you have to understand it. So we are done with this deposit function. Now let's move to the next one, which is going to be, and this particular function will transfer the deposit token. You can make it dynamic, but here I'm focusing on the deposit token. So it's going to take the amount and where we have to transfer, means transfer address. If you want to make it dynamic, you can simply take it the address of the token which you want to transfer, but we are focusing on deposit token. I will take a try and catch, and we need the exact thing. So what I will do is I'm going to simply copy this one and paste here, and we're going to do a couple of copy paste. So this looks good, and let's come here. We can take this notification and we'll say calling contract token. Then we can take our token contract, we'll say staking token object token contract. So we got our token contract. Now we can simply come back here, and we have to convert this amount. So we'll take this transfer amount, we'll say ether utils parse parser, and then we can pass the amount. So once we have the converted amount which we want to transfer, now we can simply come back here and let's make the transaction. And now we have to simply do the transfer. So let's call this approve. You can call whatever you want. Transaction, we'll say await contract object, we'll call this transfer function we have. In that we have to simply pass the two data, like the amount and the address. So first address, then amount, and it's going to make the transaction. So looks good. Now we have to wait for the transaction to be complete. So we'll say approve.wait, and once and display the notification token transfer successfully, and at the end we're going to keep it as it is. Looks good. I hope you guys can understand that how things are coming together. This is a very simple function we have built which transfer the deposit token. This is what we have. If you want to make it dynamic, make sure to import the address of the token, and that's what you can simply pass here in the token contract, and is going to receive here in the token contract like there, and you can simply add here. So in that way you can able to make dynamic transfer function, but here I'm focusing on deposit token, so I'll keep it as it is. Close this one. Now come back here. So we are done with this transfer function. Now we're going to simply move to the next function. So take a variable called async function, and this will call withdraw, because we need to withdraw the token from our staking contract. So it will take the pool ID and the amount we want to withdraw. Let's take a try and catch, and we can get the error object. So simply copy this one and paste here. Once we have that, now we can get the same information. So we'll take this notify calling contract, and we can come here, and we have to simply convert this amount in way utils parse units, and we'll pass the amount string. So we have that converted amount. Then we can simply take our contract object, await contract, we got that. Now we can simply come back here. We have to estimate the gas consumption, so we'll say gas estimation, and it's exactly the same. So we'll say await contract dot gas estimate gas, we'll call a withdraw function. In that we have to simply pass the pool ID, and we have to pass the way, the amount. It will give us the gas estimation. So once we have that, now we can simply call the actual function. So we'll take this data await contract object withdraw, and let's pass the pool ID and the way along with the gas estimation. This is gonna be gas limit, gas estimation. Got it? Now we have to wait for the transaction to be complete. So let's take a receipt. We'll say await data.wait. We have to display the notification message token transaction successful completed, then we can simply return the recipient, and this looks good. And that's the only thing we have to do for withdrawing the token out of the staking contract. So we are done with that. We are done with that. We are done with most of the important functionality. Now we can simply come back here and let's build another one. So we'll say async function, and this will be for claim reward. In that we have to take the pool ID. Same try and catch. We have to get the error object. That's what we have to paste here. And now we can simply come back here, and we need all of this information. Simply copy this one, and that's what we can paste here. Just remove this. We got that. Now we can simply come here. Now we can come here. Let's open this one and copy this gas estimation and paste here. Change the function name to claim reward. We got that. Now we have to get the transaction object as well. So it's going to take only pool ID, no amount. And we can simply come here and we can take this entire portion. Simply copy this here and paste here, and let's change the function. So this is going to be claim reward instead of withdraw, and we have to simply remove the amount, and that looks fine. And the rest should be exactly the same. Change this message. Let's call this reward claim successfully completed, and that's our claim reward function. I hope you guys can understand that how we have built this logic. We're done with this. Now we can move to the next one. Simply copy and paste here, and let's change this to create pool. It's going to take a lot of data, so we'll say pool, and this pool will have an object of data. So first thing, we have to check the data, that all the data is provided by the user or not. So first we have to deconstruct that. So let's take a variable. We'll say const, it's coming from pool, deposit token. Then we have to take the reward token, the percentage, and the last one is going to be the log day. Now we have to build a if statement to check all the data is there or not. Then reward, percentage, and log day. If any one of these data is missing, then we have to simply throw the error message. So we'll take this return and notify error. We'll say provide all the details. So that's our check. Looks good. After that, we have to call the contract and we get the contract object, and here we have to calculate the gas estimation. So let's call this add pool, because this is the function we have, and we have to pass all the data. So let's remove this, pass our deposit token. Order is very important, so make sure to pass the data in exact order. Then we have our reward token, percentage, make sure to convert into a number, and same goes with the log day, convert into a number. This is the exact data we have to provide. So this will give us the gas estimation. Now we want to simply change this to add pool, and we have to change the data as well. Simply copy this one, and that's what we can simply paste here, and looks good. And that's the only thing we have to do. In that way, we can able to create the pool. So let's rename this called stake transaction, and the rest should be fine. Let's change this to let's call pool created, successfully completed. Let's make it successful. Got it? So this is the create pool function we have. All the things are look good, no issue we have here. Close this one. Now let's write the next function. Let's move to the next function for modifying pool. So let's change this to modify pool. It's going to take the pool ID. This is fine. We need the gas estimation. Change this to pool, modify pool, and we have to simply change the function. We need the amount as well, the new amount which user is going to provide. So let's provide here. It's going to be a number, and here we have to change this, and we have to provide the amount. So simply copy and paste here. So we got the gas estimation, and the rest should be fine. In that way, we can able to modify the pool. Looks good. Change this to let's pool modify successfully. Remove this completed, and looks good. So with this modify function is ready. Now we can go to the next function called sweep, SWEEP. This function will allow us to withdraw the token out of the contract, and this particular function will take couple of arguments. So let's call this token data, and let's deconstruct that. So in that we'll have the token address. So let's call this token data. We'll have the token, and we'll have the amount which owner of the contract wants to withdraw. Let's check for a condition that all of this data is there or not. So we'll take this token is not there, or amount is not there. If any one of these data is missing, then throw this error message. We'll say notify error, data is missing. We getting this contract notification and contract object. We can change the gas estimation. So let's change this to sweep, and we need these two information like token address and the amount. So token address, and we have, let's convert this amount in transfer amount. So we'll take this ether utils parse ether amount. So it's a converted amount. Now that's the amount we have to pass here. Got it? Let's format that. Now it's good. Simply copy and exact details we have to pass here. Remove this one, pass here. Token and transfer amount. And the rest would be fine. Let's change this message to transaction completed successfully. So this is our sweep function which allow the owner of the contract to withdraw the token out of it. So we have completed all the function from our staking DApp contract. Now we have to write the function for token ICO contract. But before we start writing for our token ICO contract, let's build this function which allow user to add the token in MetaMask. So it's gonna be add token MetaMask. Let's call this export const add token MetaMask. It's gonna be nasing. It's going to take the token, and let's do that. So we're going to take this if window.ethereum is there, then only we allow to call this particular function. So we'll take this window.ethereum. In that we need to get couple of information. So we'll take const contract and we'll say await token contract. So this will give us the entire token contract so we can extract the data, because we are allowing user to add the token which the user will deposit in the contract. So we'll say const token decimal. We can get that decimal endpoint from the contract dot decimal function. Then we need the address of the token. Let's change this to token address. We got that. Then we need the symbol, and the last information we need the image of the token. So let's call this image, and this image will come from our environment variable. Remember, we have this token logo. We got that. Now we can take this try and catch block and let's try to add that in our MetaMask. So we'll take this const was added. So this will keep the status whether the token is added or failed or is about to add. It will keep all the data. So let's take that await window.ethereum request, and in that we have to pass the entire object of our token. So first is going to be the method. So we are calling this particular method wallet watch asset. Then we have to give the params. So we'll do this params. It's going to be the entire object. So it will be the type of, so we have, it's a ERC20 token. So we'll say ERC20. Then we have to pass the options. This will contain all the information about the token. So first is going to be the address. Second is going to be the symbol. Third is going to be the decimal. And the last one is going to be the image of our token. And that's the entire thing we have to pass. Now we have to check for conditions. So the status. So if was added is successful, then we have to display this notification success message that token added. If it's failed, then we have to say error. So we'll say failed to add token. Let's change the spelling to FAILED, failed. Simply copy this, and that's the same thing I'm going to display here in the catching error. And at the end, I can display that MetaMask is not installed, because that's the thing I have to keep into consideration. So let's keep it as it is. Come here and let's call this else MetaMask is not installed. So we'll say MetaMask is not installed. So this is the entire function for adding token in our MetaMask. I hope you guys can understand. It's very simple. We are getting the information about the tokens, decimal, address, symbol, logo, and we are making this particular request through Ethereum object, and this is the method we have in the MetaMask, and then changing the status and displaying the notification. So simply close this one. We are done. Now we want to start writing the functionality for our ICO contract, token ICO contract. So it's going to have 4 functions, one for updating token, update price, buy, and we're going to have a couple of more. Let's say ICO contract export. First function is going to be our buy token. Async is going to take the amount and it will have a try and catch. Let's open this one and simply copy this entire error, and that's what we can paste here. Now we can simply take our token contract, means ICO, token ICO contract. Let's say contract, we await token ICO contract, and here we have the contract object. Now what I can do is, let's simply copy and paste here, build the skeleton for other functions. So this one is going to be, for token withdraw, and it's not going to take any amount because when this function get called, it's going to withdraw the entire token. Close this one, copy, paste here. This one is for update token, and it's going to take the new address, copy, paste, and this one is going to be the price. Let's say update token price, and it will take the price. Looks good. So this is the 4 function we have to build. So let's start with the very first one, like buy token. Now in that, what we're going to do is, first we're going to display this notification calling ICO contract. Then we can come back here. Let's take this token details, and we can get it very easily because we already have the function called contract get token details. This is the function we have. You can come back to the contract token ICO, and there you will find this is the function we have, token details, get token details, copy, and that's what we can simply call it. This will give us the entire detail about the token which we are allowing user to buy. Once we have that, now we can simply come here. We can get the available token, that how many tokens is available in the contract. First we have to check the condition. If the token is not available, then we don't allow user to buy it. So let's call this ETH utils format ether. In that we can simply pass the token details dot balance, and we can simply convert it to a string. So it will give us the balance of the token. Once we have that, now we can simply build a if statement that available token, if it's greater than 1, then we want to execute it, otherwise we have to stop the transaction. So we'll take this const price and we have to convert it. So let's call this ether utils format ether. In that we can pass the token details token price, and we have to convert into a string. So in that way we can able to have the price, and we have to multiply with number of token which user wants to buy. So let's do the multiplication. So let's come here, do the multiply, and we'll convert into a number. In that we can pass the amount. So in that way we can pass the actual amount, that how many user wants to purchase, and we'll have the exact price. We got it. Once we have the price, now we can simply come here. Let's take this pay amount. Now we have to convert this amount, utils parse units, and in that we can simply pass the amount, not amount, we have to pass the price and convert it to a string, and we'll call it ether, not ethers, ether. In that way we can able to have the amount which user will pay for buying the token. So when we have the pay amount, now we can simply build a condition for the transaction. So we'll say transaction await contract. We can call this buy function. In that we can simply pass the details, number of token which user wants to take it, and is going to take the value. We'll say value means the money which user will pay, and convert it to a string, and we have to declare a gas. So here I will go with the custom gas because I tried with the dynamic one, it's what's throwing error. So let's go with this hardcode value. We'll say hexilify, and this particular value is perfect when it's come to buying the token, 60 after 8. So this is our transaction. Now we have to wait for the transaction to be complete. So let's build this receipt, and we'll say await transaction dot wait. Then we have to display the notification token transaction successfully completed. Then we can simply come back here, return the entire script. Let's go. And we have to keep that in consideration about the else block as well. So let's take a else statement. If the token is not available, then we can simply display the error message. We'll say notify error. insufficient, like token balance is low than expected. Looks good. And at the end we want to simply return the simple text. So let's copy and call it string script, and that's our buy function. I hope you guys can understand. It's very simple. We are checking for the supply, then we are making the transaction and converting all this. Very good. Now we can start with the withdrawal function. Simply copy this one, and that's what we can simply paste here. Notification, and simply change. Let's keep it. Come back here, and here we have this. Simply copy this one because we have to check whether the token is available or not. So simply copy, and that's what we can call it. Now we have to check the if block. So simply copy all of this, and that's what we can paste here. Now we're going to simply change this. So this is fine. We have to remove the price, this section, remove it, and we have to make the transaction only. So here we're going to simply call the withdraw function, this particular one, withdraw all token, copy, and that's function we have to call it. Remove all of this data, and the rest should be fine. It's going to simply withdraw the fund out of our ICO contract. Got it. Close this one. Our withdraw function is done. Now we can start working on our update token. So first we have to check whether the token address is available or not. So let's build the if statement. If address is not there, then we can simply throw the error message like data is missing. After that we can simply perform the transaction. So let's come here. I can simply come here and grab the same details from here. So simply copy at this portion and paste here, and we can come close this one. We need this gas estimation as well. Simply copy, and we can simply paste here. So we got our gas estimation and all of this data. Now let's change the functions. Come back here, and this is the function we have, update token, copy, and that's what we can call it here. And here let's copy the address and paste here, and change this and paste the address here as well, and this is fine. Let's replace the address here, and we have to update the gas estimation, and the rest to be fine. This looks good. Now we can simply take the gas estimation and change it here. Now this function is ready. This will allow us to update the address of the token in the contract, and the rest should be fine. Just keep it as it is. Simply copy this one. Now we have to build the RAS function. Let's paste and check for price is available or not. Simply copy and paste here. Now we have to do exactly the same thing. So let's build this pay amount, and we have to convert this amount, and that's what we have to pass in the function. So we'll say parse unit, in that we'll say pi ether price to string, and it's ether. Got it? Now we can simply come here and simply copy this portion and paste here. First we have to change the function name. So let's come back to the contract price and paste here in two places. Once we're done with that, now we have to simply change the price and change here as well, and the rest should be fine. Looks good. So this is our entire function for updating the price. So we are done with this entire index file. We have imported all of these functions and the libraries. Here we have the environment variable, notification, and this is our utility function for converting time, way, parse error, short address, copy address, and here we have the other function like contract data, deposit, transfer token, withdraw, claim reward, create pool, modify, we have sweep, we have add token, metamask, buy token, token withdraw, like update token, update price. So all things looks good. We're done with that. Simply close all of this open file. This is also look good, this is also look good, and if we find that we need to do any modification in the functions, we can do that as per our requirement, but this is the structure we are following. So remove this one, remove this one, remove this one. So we're done with this. Now we're going to simply come back to the pages, go to the app.js, and here we have to do the configuration of our wallet providers, which is going to add multiple wallet, and that's the setup we're going to do. So that's the only thing I want to cover in this video. In the next video, we're going to start working on our crypto wallet, and we're going to build a couple of components in our front end. So let's move to that next video.